Problem 37. Given epsilon equals 0.03 and this limit, find delta so the definition of limit is satisfied. So first recall the definition of limit. The limit is x goes to c of f of x equals L. This means that given any epsilon, a positive number epsilon, we can find a positive number delta so that as long as x is within delta of c, then f of x will be within epsilon of L. So our goal on this, what we need, is this second part of definition of limit to be satisfied. We need f of x minus L to be less than epsilon. So our f of x, the function that we're taking the limit of in this case, is x squared. The limit is 4. And epsilon was given as 0.03. Now we can factor this up to write this as absolute value of x plus 2 times absolute value of x minus 2 is less than 0.03. Now x minus 2, that'll be the x minus c that we're getting from the definition of limit. The x plus 2 we need to do something with though. So given that x minus 2 is less than delta, that's what the preceding part of the definition of limit was, x minus c is less than delta. This says that x minus 2 is then less than delta and greater than negative delta. Now we ultimately want to say something about x plus 2. So what we'll do from here is add 4 to all three sides of this inequality. So we've got 4 minus delta less than x plus 2 less than 4 plus delta. And here let's make a restriction. Let's impose the constraint that delta is going to be small. It's going to be less than 1. If delta is less than 1, that tells us that x plus 2 is then between 5 and 3. So that means here, if we were to solve this for x minus 2, we have x minus 2 is less than 0.03 divided by absolute value of x plus 2. And we want to look for the worst case scenario here. If we wanted to make this fraction as small as possible, that would happen when the denominator is as large as possible. And x plus 2 is always less than 5. So this lets us say that x minus 2 is less than 0.03 over 5, or x minus 2 is less than 0.006. So that means that our delta can be any number less than 0.006.